collect the data quickly. We need to collect data parallel to our production to be more productive. And how can we assure that the welds that we have done on a certain product, doesn't matter what it is it a bridge, is it a rooftop in a stadium, is it some piece of safety metal for people that are climbing on the roof or whatever, we need to make sure that the data is collected and linked to that product, so that in a case that something happen, or in case that just somebody is asking, we can provide all the information without searching for days. And this leads me to the next point, that welding is not that simple anymore like it was 10 or 20 years before. Because if you start to weld 20 years before, you have had maybe some documents that you need to fulfill. You have some norms that you need to fulfill, and you need to document that kind of norms and standards. And if you have done this, then everything is fine. So somebody's ordering a product and you're just welding that product, and then you're just delivering that product. And that's basically it. And I have talked with a lot of managers from productions, and most of them told me the same story. So they said, when we have done the products 10 years before, and most of the, industry products, like, for example, heavy industry, like bridges, or, they haven't changed. The technology of bridges haven't changed the last 10 years. So the last 10 years, we are building the same constructions in bridges. We are welding with the same materials, with the same wires, and mostly with the same welding machines even, because the welding machines are not breaking down. So the machine is even the same that was used 10 years ago. And that brings me to the point that the work haven't changed the last 10 years on bridges, especially on that example right now. And the product, or the end product, is mostly the same from the technology, from the materials, from everything what was put it inside that product. But what has changed is the value, or the quantity of the recordings, of the documentation. And these managers, they have spoken about 8 times more documentation than before 10 years. So that means that you do exactly the same things with exactly the same machines, exactly the same wires and gases. But now the request is that you have to document more and more. And that leads you to the point that you need to fulfill it somehow. And somehow most of the time is first serve first. You use a pencil and a piece of paper, and then you write down all the parameters. You write down the WPSs, and you say, okay, I have a WPS, I have a WPQR. They are linked together. I have them in a folder, and the folder is somewhere here in my office. And I have certificates of the welders, and these certificates, they are also in that folder. And then I have the parameters of the welding machines. I have seen them with my own eyes, and I have written them down on a piece of paper, and I have the order, and now I need to link this together to make the documentation clear. And there are a lot of wordings that are now linked to the welding. So if you start welding, it's not only welding anymore. With welding, you have a big responsibility. You need to you need to make sure that the welding time is correct, that the documentation is correct. You have WPSs, welding machines, rules and standards, quality, welding plan, and so on and so on. And therefore, we have created a kind of quality circle of welding, if you want. So Welding 4.0 in welding production. we want to summarize it in that slide. So you have component information that you need to collect. So how many welding is inside that component? What kind of welding preparation is inside that component? How many times do we need to weld that welding component? Then we have the welding equipment. So we need to choose the right welding equipment. In that kind, or in between the welding equipment and the process, we have predictive maintenance. So do we weld until the welding process breaks down because of the torch? Maybe the torch is very old, the torch is damaged, the contact tip is damaged, whatever. And then the process breaks down and I need to maintain the welding machine before I restart the process. Problem is that I have then maybe an error in my welding because I have just stopped during the welding. So predictive maintenance is a big point. How can I do predictive maintenance without any tools? Can I say, okay, I will change the contact tips every morning on every torch just to have predictive maintenance? Or is there any simple solution that give me a light or something or a noise and say, hey, you have welded now for 10 hours, change the contact tip or something? Then we have the process itself. So we have to choose the right process if we want to weld a certain component. Then we have to choose the right employees which are certified to do that kind of task. You cannot just have somebody to do something. You need to have somebody who's certified to do certain things. And then we are coming to the documentation, and documentation point, like I said, in the last 10 years has more than multiplied. So, 8 times more than 10 years before. And there we are coming to monitoring in real time. So how can we monitoring the welding process and the documentation stages or the production stages in real time? Is that possible somehow? Without having a lot of different softwares and different adapters and different, equipment to monitor one welding machine or maybe 2 welding machines. So how can we do it globally on our company? And then of course we have the result, and we have something to do with that result. And this is the circle of welding, what we need to fulfill just to understand the complete package or the complete meaning of Industry 4.0 or the meaning of Welding 4.0. And the requirements for that is network equipment. So we need to establish a network inside our production. And not every company is using, Wi-Fi or Ethernet in their production. So this is the first challenge in my digitalization of welding productions, because most of the welding productions, or not most, let me say some of them that I have visited, they haven't changed in the last 40 years. So all the buildings, they are quite new if you are looking on the office side, where the customers are coming in, office, some conference rooms, whatever, newest technology, everything, the best what the market can give you. But if you step into the welding production, it seems that nobody has changed something the last 40 years. So they are working like 40 years ago. And this is, of course, a challenge to change the mindset of the people and say, we want to go ahead and let's do some change. And the change is not, to change you or criticize you or tell you that your work was bad and we need to change to make it better. We need to go ahead together. We need to, step further together and make that steps together to grow and to maximize our efficiency, to maximize our productivity. And of course, we need to have digital qualification also of the welders. So we have a lot of paperwork to do. And here I coming to the benefit of the real-time monitoring. So we have just talked about real-time monitoring. How can we do that? And what is the benefit out of it? Because a lot of people are asking me, hey, why should I record welding data? Why should I record parameters? And what is the reason for that? I just can let them weld. I don't need to record anything. Why should I do that? Because if I record welding parameters, then I'm overwatching my personnel, and they don't want that. And overwatching the personnel is a thing that we are doing already for many years. And we are not overwatching personnel to, again, criticize them and to say, okay, your work was bad, or you have welded to less hours the day, or whatever. For example, I am in the sales department, and I am tracking my daily work every day. So I'm tracking every meeting. I'm doing, protocols out of the meeting. My boss knows where I'm going. My boss knows where I'm today. And I want him to know what I'm doing, because I want that my boss can see how good my work is. So I want him to know every single time what I'm doing. Maybe not right now, but the communication is very important, because then he knows, okay, look here, here's a project, here's whatever, an order. So we have a good communication inside our company. And this communication needs to be also done in the welding. And I am recording welding data, not on that person. So there's not written a name like Stanislav Wiens is welding here. I'm just recording data on that machine to have predictive maintenance. So to step into welding 4.0, it is very important to take all of your personnel on that, in that boat, and give people a feeling that we are doing it together, and it's nothing against you. We are doing it together, and you are a good worker. Why are you afraid that somebody can see how many you are welding? Because you are welding a lot of time in one day. So you don't need to be afraid about that. So benefits of the real welding is conventional. So we have preparation, of course. Then we are coming to the welding. After the welding, we need cool down time. Then we are testing. And if something is wrong with that product, oh, sorry, there's a dog barking. So just check out if your microphone is not muted, and please mute your microphone. So we need to test that piece and then repair it. Maybe repair if we have a potential failure inside. So this means that we have long reaction times, because we weld and then we test. So we have higher cost of repair, because as thicker the component is, as more time we need to repair it. In welding 4.0, we have the preparation, we have welding monitoring in real time, and this gives you a real feedback all the time. So you as a welding coordinator or as a welder, you will getting a real-time feedback from your machine, because the machine can tell you, okay, you have exceeded some kind of parameters, and now I'm giving you the possibility to decide, are we going ahead? Are we finishing our work? Or should we test right now before we finish the component? Yeah, so this gives you a shorter reaction time and a lower cost of repair. And this is significantly inside a production or heavy industry production. And if you look on the side of the predictive maintenance with for example, contact tips or torches or wire feeding units, whatever, in the conventional welding, you have the situation that you weld, then it starts to go down with the quality of the torch, for example, or the contact tip, whatever, some working products like the torch, like the wire feeding unit, like the rollers on the wire feeding unit. So it's going down with the quality, and on one point it just is broken. And then your quality is just going down, because on that point, if you just stop the arc and maybe the wire is sticking inside your molten pool, then you need to repair, you need to grind, you need to cut, you need to change the torch, and so on and so on and so on. So that means that on the time where the quality is going down, you're still welding. So that means that your quality on welding is decreasing, and it's decreasing till it collapses. And when it collapsed, then you have to maintain. So the maintenance is coming, it's coming very unexpectedly. And then you need time to, bring some contact tips, maybe bring some new rolls, cut the wire, maybe the torch is broken, you need a completely new torch, and so on. In Welding 4.0, the idea is that the machine is giving you an information about the time you welded already. So you have, again, the possibility to react. It not means that you need to react or you have to do it every 2 hours or something. Yeah. The time you can set by yourself. So it's your experience, what is necessary to set a correct timing. And with this correct timing, you can just keep your quality on the highest level and shorten your maintenance time. And we need to do it in four simple steps. So how can we put XNet or put Welding 4.0 inside our production? And this is an actual picture of one customer of us who's welding and recording data with that kind of tool. And he's looking on the data right now and can see it in a real time. So you can see now this on the picture is the real time view. But before we start with the 4 steps, I just want to give you a feeling about what happened here in Germany or in Europe in the last times. And I don't want to scare you, but this was a shocking moment in 2019, where the rooftop on a stadium in the Netherlands was just dropping because of wind. And it was a playing day, so it was a Sunday. Sunday normally we are playing soccer, and the good news was that the organizer of that game, they said, okay, it's too windy, we cannot play today. It's too windy. It doesn't make any sense, because when we kick the ball, then it's just flying around because it's so windy, we cannot play. So they canceled the game, and this was very luckily because this wind was like you can see, it was so strong that the rooftop came down. And the investigation shows that a lot of welds on that roof, there were no welds. They forgot to weld. So a lot of welds were forgotten, and some of the welds there were not strong enough. So you see, maybe there was a calculation failure. Maybe just somebody forgot in the production, the welds, whatever else. So, but luckily nobody was hurt. So the investigation is closed right now. And I said, okay, there were welds forgot. There were, welds too weak, and they need to improve that. And how can they do it if they don't have any tools which can give them an information? Hey, you have forgotten some welds on that project. You need to do 2,500 welds, and you have done 2,300 welds. So where are they? Where are the 200 missing welds? Okay. Another thing is happened here in Germany. I think 6 months ago, if I'm not wrong, but it was not very long time ago. So you see that bricks or that kind of walls here on our speedways, and they are protecting the other peoples on the other side who live there. So they are noise canceling walls. And one of this noise canceling wall was suddenly just dropping down. Just like that. It was just dropping down on the road. And it was falling down on a car. So you can see the car here. And unfortunately, there was a woman, and this woman died on that accident because that wall came down. And the reason for that wall was, again, welding. It was welding. It was welding here and under a destination with that bolts. So 2 weak bolts, 2 weak materials, and 2 weak welds. So they had to, check all the walls here on that part of the road to make sure that the work was done correctly. But you can see here, it's very thin material, just welded together. I don't know what this is, why it's laying here. And this company just mounted the walls like this were, I don't know, 10 kilogram walls, but this were actually tons of material that these small pieces here have to hold. You know, and how can you now tell everybody that no, we have not done any mistake because we have recorded everything? These companies haven't recorded anything, so nobody knows who was welder, what kind of material were used. Nothing was recorded. So a big problem here to now get the responsible persons, and if they get the responsible persons, then it's a very, very big problem for them to, you know, make sure to show them, hey, here's the documentation, because there's no documentation. Another customer of mine is constructing this little pieces, or kind of, it's not actually this piece, it's a kind of this thing, and it's a safety tool for people who are working on rooftops. Like you can see here, you just can link together with your safety equipment, and then you are safe not to fall down from the roof. It's very important because if you're working on a roof, then it's very important not to fall down from the roof. And this kind of thing is helping you out. And it's very, very important for them to record every single weld on that construction. Because if somebody, so it never happened, but if somebody is falling from the roof and, for example, breaking the leg or breaking the arm, then they need to make sure that all the welding data were correct. So they can say, here's the documentation, and calculations were right, welds were right, certifications of personnel were right. So maybe the accident happened not because of the welding. So maybe there's another thing. Maybe some of the safety pieces that the worker was wearing was not okay, or whatever. So, but they can make sure that the people know, yep, that was okay, there's no failure. So this is a big point for Industry 4.0, or Welding 4.0, to make sure that you are recording your welding data and can link them to a certain project, or can link them to one piece of metal. And it's working very simple. So everybody of you, I think, has a server, and you just need a server to install that kind of product, to install XNet on that server. And you can link every welding machine from EWM by using Wi-Fi or even Ethernet with a piece of gateway. So it's kind of external gateway that is collecting information from the welding machine and sending it over to the server, and the other way around. If the server is communicating with the welding machine and sending it back to the and sending it back to the welding machine. And of course, you can use equipment like an adapter for alien machines. So if you use not EWM machines, okay, because the main idea of Industry 4.0 is connect everything inside your production, and you don't need to, you know, to change on one fabricator. Even if I would be happy if you just use EWM, of course, but if you don't use EWM, you can equip your welding equipment or welding machines with an adapter and use them also in XNet. And you can then access, of course, from every browser and every device, iOS, Apple, Windows, whatever. Just short question before I go ahead. What, how many time do I have? Because I know it was 45 minutes or 30 minutes. I'm actually not sure. Sorry for that. But just give me short info. How much time do I have? Or just write it down in the comments, please. How many time do I have? Write it down in the comments, and then I just proceed. Good. What is about your what is about your WPSs and WPQRs? And for that one, we have created our own PQR maker with our own welding a drawing tool. So you can see that we can do some very decent drawings. So I like that tool very well because it's reacting dynamically on your typings. So what you type in here on that information, what kind of plate you have and what kind of material thickness, the drawing will react dynamically, and that gives you a very nice overview what you need to do right now. So you need to create, of course, that kind of documents, so like your welding procedures. Of course, you need to do the same thing with the welders. So put the certificates inside the system, because we have here welder management. So the welder management gives you the possibility to print a welder certificate, or to sign the welder certificate inside the system. So the complete prolongation tool is inside Ixnet. You don't need to make the signatures on the real paper anymore. You can do it inside the digital system. So step 2 basically is to put your component inside Ixnet. So like this little piece, you see, this is a kind of component. I don't know what this is. The customer is welding that kind of stuff. I think it is actually an oven for your kitchen, so where you can just cook your things. So even this needs to be documented, and they have linked all the WPSs to all the different seams. So you have a detailed display of all the different views, and you can see all the welding seams which needs to be created. You have barcodes on that, so that you can scan it from screen, or you can scan it from paper, whatever you prefer. And step 3 is to identify the welder with the X button. So we have here a small kind of chip reading device, and you can put the certificates and the name of the welder on the chip, and then he or she can register on the welding machine and link the name to that product. You can say, okay, I was the welder of that product, and you don't need to do it by hand with a pencil or something. I have seen productions where they have big drawing of the product, and every welder got his own color. For example, yellow, green, red, blue, whatever. And then they were drawing on that drawing in color what they have done. So in yellow, I have done this weld and this weld and this and this and this and this, and then blue and green. So you have a big drawing with, I don't know, 10 different colors inside that. So it was like, like a book in the kindergarten where they just, draw something in color. So absolutely, from my point of view, sorry to say, but from my point of view, absolutely ridiculous to, use that kind of documentation. Who was the welder? So you can do it very simple, like linking it to the welding machine, and then you know what kind of welds you have done. And then you can display all that kind of stuff on your torch. So even if you then use the EWM torches, of course, it's not necessary to use EWM torches, because you can do everything with your scanner. But the benefit of using the welding torch is that even the torch is showing you the information what you need to know. So you can see it's now seam number 4, and it's the run number 1 of that seam. And you can confirm through the torch that you have welded, and then the machine is jumping to the next WPS and changing the parameters on the welding machine. So yes, if you use EWM equipment, then you can link the WPS to that component. And by scanning the component, the welding machine is setting up the parameters just right in that WPS. And this is a big benefit. If you, for example, use alien machines from another manufacturers, then of course, Ixnet cannot tell them to set up the parameters. So that means that you can record everything, but you cannot communicate from the server side to the welding machine. So that means the welding machine stays open for everyone. Okay, with EWM equipment, you can kind of lock it, or bring it in a direction, in a way where they need to go. So you give them a feeling about the parameters, how many wire feed speed and voltage correction you need to set up, because the WPS is giving you a range. Oh yeah, let's quickly jump over this slide. So this is just for understanding how the process can work. So you scan the barcode for the order number, whatever batch, component group. So you can scan a lot of things. It depends on what you want to collect, what kind of info you want to collect. Then you log in on the welding machine so that you have also the welder information. So you can hear the component identification with all that kind of info you have, welder identification. Then you do the welding. So manual setup or automatic setup. Automatic setup, like I said, is when you scan the component and the welding, the WPS is linked to it, then the machine can set up the parameters, but you can do it also manually. Then you have the real-time monitoring. So you have always a link to that component. You can always have a look on the parameters in live. And after that, you have statistics in XNet, or you can export all the tools to BI. BI tools, you can download them free of charge. I think Power BI is a free of charge tool to, make some links to a database, to a certain database, and then make your own graphs, your own graphics, your own statistics, whatever. Export it to a CSV file, for example, WPS, welder certificates, whatever. So you have a result, you have an insight into your production, you have an insight in your order, and you always know on which step are we right now. So for the welding coordinators, you have the monitoring and the dashboard, so you can see from one view what is the consumption, welding data, whatever. This is the real-time view, actually. So just to give a feeling, these are the parameters you can uncheck. So these boxes you can uncheck. This is welding current, welding voltage. Sorry for having that slide in German. So this was just a screenshot, but this is the welding current, voltage, wire feed speed, even the gas we are recording if you use, again, welding equipment from EWM, because we have a gas sensor inside the wire feeding unit. Motor current, you can measure the motor current. The motor current is a value that gives you a feeling about the stages of your torch. Because if the motor current of your wire feeding system is increasing, that means that the motor is pushing the wire very hard. And if that's the case, then you know that your torch is dirty, broken, or just, used. And this can be an indicator for you. So if the motor current is increasing more than, I would say, 1.5, 1.8 amps, then I would have a look on my torch. So this is an overview about your welding data. So this is actually this word, Schweißdaten. This means welding data. And welding data is showing you on that certain day. So now it's filtered just by the date. It's not filtered on order number or whatever. We have filtered it just by the date, so you can see all the weldings. And it's filtered here with the monitoring even. So you see this seams, they were not monitored. So I don't want to monitor my whole production. I just want to monitor very, very, sensitive welds. When I know, okay, these are safety welds. Maybe if there's something broken, then people can be damaged. Yeah, so human life can be damaged. And then I need to record that. I need to monitor that. And you see here, this is not monitored. So I assume that this was not, safety reasons, no safety seams. There were okay. Here we have 4 warnings. We got 4 warnings, one in amp voltage, but it's just a warning, okay? So I have set the parameters by myself. Me as a welding coordinator, I can set up my parameters and can say, you give me a warning if you exceed whatever, 20%. You give me a failure if you exceed 30%. So you see, this is a potential error. This is a warning, just to have a feeling about that. We have a project. For example, this was now the component number, and we have the component number even here. So, okay, it's just pointing there, but it should point here. And here's the same. So if I then just choose a weld from that component, then I can take a closer look to my component, and I see this was the component blah, 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 and the seam number 8. So I can see the seam number 8. And this was the welding on seam number 8. Looks quite okay till here. So maybe, I don't know what happened here. The arc was a bit too long maybe. So it was just, jumping down and up again. I don't know what here the reason was. So it was micmac pulse. You can see with a 1.0 millimeter wire, and now we can do some investigation. And just give me a short 1 minute, and then we can do our wrap up. Let's have a look on that. So this is a kind of report then. And also the welding machine gives you an indicator. So it's not only for the welding coordinators, also the welders can get a warning on a light, on a LED. And this is a maintenance overview, so you can set up your timers, what we have spoken already before all the time. And this is again a summary evaluation about that kind of stuff, so you can see your efficiency. And this is a slide, but you can see them by yourself. I don't want to, show you or read all with you all that stuff, but this is just the norm or the standard that we fulfill or that we support with XNet. And this is an example if you export all that stuff to Power BI from Microsoft or whatever, so you can build up your own graphs, graphics, sketches, whatever. So this is kind of overview. Good, everybody. Thank you very much for having me. Thank you very much for the time. So if you have any questions, let me know. So let's do a quick wrap up.
So thank you, Stanislav Williams of EWM. Maybe we can have a Q&A after the presentation of the two speakers. Thank you again, Stanislav from EWM. So for our second speaker,